tan theta is sine theta over cosine theta. Please memorize that basic identity. Let's draw a nice right triangle. And we have a y value for the height, and we have an x value for the width, and we have an angle theta. Remember the acronym SOHCAHTOA. S stands for sine, and sine theta is opposite over hypotenuse. In this case, the opposite is y, and the hypotenuse, we'll call this h, and the hypotenuse is equals to the radius of a circle. So sine theta is y over h. Now what is cosine theta? C represents cos. Cos theta is adjacent over hypotenuse, and adjacent is the side that's beside theta, but not the hypotenuse, which is x over h. Finally, we have T for tan theta, and tan theta is opposite over adjacent. Opposite is y, and adjacent is x. Now, is it true that tan theta is sine over cos? Let's verify this fact. Recall that sine theta is y over h, and cosine theta is x over h. What is sine over cos anyways? Sine theta over cos theta is this divided by this, y over h divided by x over h. Using algebra, we have y over h multiplied by the reciprocal, which is h over x, and we see the h's cancel out. Thus we have sine over cos is y over x. Thus, indeed, tan theta is y over x. So the definition of tan theta is sine theta over cosine theta. Let's memorize the primary trig ratios by drawing a triangle, particularly an equilateral triangle that happens to be 2, 2, 2. So let's chop this triangle in half. What is half of 2? We have 1. So focusing on the right part here, we see this triangle is very special. We have 1, 2, and we have an unknown height x. In an equilateral triangle, we have the angle 60, 60, 60. All the angles are the same, all the sides are the same, and 180 degrees, the sum of the angles of a triangle, divided by 3 is 60. So we have 60 here, we have 90 degrees, and we have half of 60, which is 30 degrees. This famous triangle is good to memorize. Let's use the Pythagorean theorem to figure out x. X squared plus 1 squared equals the hypotenuse squared. X squared plus 1 equals 4. We'll throw the positive 1 over, so 4 minus 1 is 3. So x equals the square root of 3. Now let's draw another very special triangle. The other special triangle has an angle of 45 degrees, 45, 45, and it's isosceles. 1, 1, and we'll call this C for the hypotenuse. Again, we'll use the Pythagorean theorem. C squared equals 1 squared plus 1 squared. Thus, C squared equals 1 plus 1, which is 2. Taking the square root of both sides, we have C equals root 2. So please memorize the 1, 1 root 2 triangle, as well as the 1, 2 root 3 triangle. The longest side is 2, the hypotenuse, and this is 30 degrees and 60.